we'll be understanding the idea behind complex numbers. Let's consider the following quadratic equation. X squared plus 1 equals 0. And let's see what to solve for x. So we have x squared equals negative 1. But we have x equals the square root of negative 1. So what does this actually mean? This is actually considered a complex number. But what are complex numbers? So the imaginary number I is equal to the square root of negative 1, where I squared is equal to negative 1. When a complex number is added to I, the result is a number in the complex number system. For any real numbers a and b, a complex number has two parts. The standard form of a complex number is a plus bi. Every number is technically a complex number. For instance, the integer 4 is also technically a complex number, as it can be rewritten as 4 plus 0i. And something such as 2i can be rewritten as 0 plus 2i. And a complex number is also considered 5 plus 3i, where 5 is the a value and 3 is the b value. Now let's find patterns within complex numbers. So let's recall that I is equal to the square root of negative 1, and that's just I. And this I squared is equal to negative 1. And I cubed is equal to negative I, or negative times the square root of negative 1. And I to the power of 4 is just equal to I squared times I squared, which is equal to 1. Or I cubed times I. And we can continue on this process. I to the power of 5 is equal to I, and I to the power of 6 is equal to negative 1, because I to the power of 5, which is I, times I is negative 1. And I to the power of 7 is negative I, and the process continues. I to the power of 8 is 1. Now you may be able to notice a repeating pattern, and indeed you are correct. This cycle does repeat. As you can see, I to the power of an integer value would either end up in I, negative 1, negative I, or 1. And it actually follows that pattern. As you can see, I to the power of 1 is I to the power of 2 is negative 1, and so on. Now let's utilize this pattern. Let's say we have to find what is I to the power of 57 equivalent to. Well, as we know, the cycle repeats every 4 times. What we can do is we can divide 57 divided by 4 to see exactly how many times this cycle is repeating. And we get 14 remainder 1, which is equivalent to I. So, in other words, we can rewrite I to the power of 57 as I to the power of 4 to the power of 14, since the cycle is repeating 14 times I, because that's the remainder. Since we have remainder 1, that's just I to the power of 1, which is equivalent to I. And we know that I to the power of 4 is equivalent to 1. So I to the power of 14 times I is just simply I. So we get that I to the power of 57 is equivalent to I. Hope this video helped. Comment down below any other math topics from your review. Thank you.